Hello, pre-calculus. In this video, we are going to talk about hyperbolas within our conic sections. That's in Unit 10. So we're going to talk about hyperbolas. A hyperbola looks like two mirrored parabolas. It's just fun to say these words. The two halves are called branches. And a hyperbola has two vertices. Has two foci as well, but we're not going to mess with those. Hyperbolas also have asymptotes. Everybody loves asymptotes. Okay, so when we talk about the types of hyperbolas, just like ellipses, we have vertical and horizontal hyperbolas. So a vertical hyperbola will look like this, and a horizontal hyperbola will look like this. Now, the reason we have asymptotes for hyperbolas is that they do this, okay? They guide how wide our hyperbolas are going to open. So that's why we need asymptotes for these. Okay, so the very first thing we're going to do is look at these equations. Notice that A is always under X and B is always under Y. Also notice that hyperbolas, the initial fraction is positive, and then the next one is negative, okay? That is a key for determining whether or not you have an ellipse or a hyperbola, because in an ellipse, your two fractions are always positive, and in a hyperbola, you always have one that's negative. All right, so let's look at this first example here to kind of get an idea of what this would look like. So the first thing we're going to do for this problem, we're going to find the center, we're going to find our asymptotes, and we're going to graph this. All right, so the center, since we've got just y squared and x squared, that means our center is at 0, 0. So that's going to be right here. And a squared, of course, is under x squared. So that's going to be 4, and then the square root of that is 2. And then b squared is 9, and b, the square root of that, is going to be 3. So the y fraction is the positive one, so that's how we know we're dealing with a vertical asymptote. A vertical hyperbola. Sorry about that. We do have asymptotes. I just need to show you where they go. So our slope of our asymptotes, I want you to notice up here in the general information, the slope is right here at plus or minus b over a. So for this particular situation, the slope is plus and minus b over a, so 3 over 2. All right, so how does this work? Well, the first thing I'm going to do once I get my center on my graph, I am going to draw my asymptotes. So I've got positive 3 over 2. So from the center, I'm going to go up 3 over 2, up 3 over 2, up 3 over 2, and then in the opposite direction, down 3 over 2, down 3 over 2, down 3 over 2. So there's one of my asymptotes right there. And then I'm going to have one in the negative direction. So from the center, I'm going to go up 3 over 2 in the other direction, because that's my negative slope. And then I've got exactly what that will look like. So I know how wide to make the branches of my hyperbola. Now I've just got to figure out where they go. So if you'll notice this, since we've got a vertical hyperbola, that means from the center we're going to measure up 3. Put my vertex right there. And I'm going to measure down 3. And I've got a vertex right there. And that's all there is to that. It's easy peasy, lemon squeezy. All right, so let's see. I think I will do the other examples in another video, so you will have shorter videos.